Okay, find the nth term for the sequence. There are a couple of ways you can do this. We have to be careful because on the STAR test they may give you an nth term that's not linear. I'm going to show you what to do when it is linear. Remember, this is the y value, that's the result, and the x value. Let me rewrite this sequence so that I can write on top of it. This is the y value. The x value is going to be 1, first one, second one, third one, fourth one, fifth one, sixth one. And this is 0. So this would be the y-intercept. This is going down by 5 because I started -1 and I'm going down to -6, down to -11. So I need to come back up 5. Now what would that look like? Well, on a number line, here's -1, 0, 2, 3, 4, 5, 6. So start here and go up 5. 1, 2, 3, 4, 5. You're at 4. So this number is 4. So since this equation, or excuse me, this sequence went down 5, it's -5, and it starts at +4, that means -5x plus 4. And this would be the answer, but the answer choices are going to look like this. Same difference. Let's do this one down here. If the pattern continues, which expression can be used to find the nth term? So the fifth term, there are 5 terms in a pattern shown below. I want to know which one of these gives you that. Well, remember, these are the y values, which means the x values are 1, 2, 3, 4, and 5. There are a couple of ways to do this. They're decimals, probably not so easy to do it the way I did it here. Since 90% of the test is going to be linear, I say do menu 613. And this is a point, and this is a point. So x's, y's. Control squiggly lines, 1, comma 2. Control right, -0.5, comma, -0.25. Make sure I got everything right. X and X, X and X, Y and Y. They're both negative. We put the decimal in the right spot. So now we press enter, and it tells me that it's 0.25 next to X and then minus 0.75. So which one has minus 0.75? There it is. It tells me 0.25 for N, and then a negative 0.75. There it is. Okay, so menu 613. Remember, you can use that whenever you have 2 points to write the equation of the line. Let's see what else we have. Oh, I don't like this one. The fact that I have 3 sequence problems back to back gives me 3 ways to show you to do them. So I notice that there are squares here, so do not use menu 613. Menu 613 is only for linear. If I have a square as an exponent, that means it's quadratic. So what we have to do is work this problem out the way it's meant to be worked. The N is the position. So what position are these in? This is in position 1, position 2, position 3, position 4, position 5, position 6. This, however, is what they call AN, which is the result. So that means these numbers are the answers. Once you plug in the position, which is not given. They don't ever give in. And the reason people miss this question is because they take these numbers and they plug them in. That's not what you do. You take what position it's in and plug it in to get the answer that you see given on the problem. So for number 1, I'm going to say 2 times 1 over 3, which is, and if you have to put in the calculator, do so, 2/3. But that says 1/3, so that can't be it. 2 says n squared over 3, which means plug in 1. 1 squared over 3 is 1/3. So I got that one. Now plug in 2. 2 squared over 3 is 4 to the third power. And that's what it says. Now we take 3, the third position. Not him, not that 3, but this one, because it's talking about the position. N is the position, the row that you don't see. So that would be 3 squared minus 3, which is 9 over 3, which is 3. So that one works. Now we plug in 4. 4 squared over 3 is 16 over 3. So that one works. Plug in 5th position. 5 squared over 3 is 25 over 3. That one works. Plug in the 6th position. 6 squared over 3 is 36 over 3, which is 12. Wow. Answer is B. I'm glad the answer is B, because I didn't want to do all this for C and D. Okay, moving on. The graph shows the cost of purchasing X flags at a gift shop if the flags are equally priced. Based on this information, which ordered pair represents an additional point on the graph? Well, I noticed that the slope here, it's linear, so I can talk about slope. The slope is up 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. So rise, 1, 2, 3, 4 over 1. So I need to rise and figure out which one of these will be a point on the graph. So I need to go up 4, 1, 2, 3, 4 over 1. So this is 20, and that will be 21, and that is 5. So 5 needs to be a 21, and it's not. Okay, so you can keep doing that and draw extra lines and find the answer, or take this point, which is 1, 5, take this point, which is 2, 9, and use menu 613. I would. So I'm going to type in the calculator for the X list, 1 and 2, squiggly brackets for the Y list, 5 and 9, and menu 613, squiggly lines 1, 2, squiggly lines 5, 9, and it tells me 4x plus 1. Okay, now that I have the equation, I can plug these in. That's the x value. So 4 times 8 is what? Do you know? Okay. Add 1 to it. Do you get 34? Yes or no? So 32 plus 1 is 33. I need 34. Not correct. Let's do the 6. Plug in the 6. 4 times 6 is, add 1 to it. What'd you get? Is it 24? Well, 4 times 6 is 24. You add 1 to it, you get 25. So it's not that one. It has to be D. You could have also looked on the table. So Control Doc, add a graph, 4x plus 1, enter, look at the table, and look for 729, and it's there. You could have looked for 6 and see if you get 24, and it's 25. So, answer is D. Write the equation of the line that has a slope of 0 that passes through this point. Well, when I have slope 0, I am only a y value, so it is y equals -5. And to write that in function notation, it would be f of x equals -5. Slope 0 is a horizontal line because it's a y value. That's why we only pay attention to the line. It says write an equation of a line that has a slope of undefined that passes through that same point. So we're only looking at x values. That is when the slope is undefined, when you have a vertical line. That's an x value. So x equals 3. You cannot write it in function notation because it is not a function. Okay. Now we get to talk about direct variation. Y varies directly with x. That means I can set my table up and cross multiply. So 1 goes here, -3 goes here, -6 goes here, and I don't know why. So we cross multiply. That times that is +18, and then divide by the 1, and you get 18. So the answer is C. You do the same thing on this next question, except it doesn't say y varies directly with x. It says mass, so y, varies directly with volume, so x. So when you set up your table, your x is volume and your mass is y. Then it says that the volume is 80. So 80, that means 100 kilograms is the mass. And it says the volume in liters is the volume. The volume is what is the volume in liters when you have 3.2 kilograms? So be careful, because if you put 3.2 here, you'll miss the question. So it has to go here. We multiply 80 times 3.2. If you have to use the calculator, do so. If you're going to do it by hand, do it by hand. But it gives me 256. So I'm done with those two. Now divide off the 100, and you get 256. The mass varies inversely. So this problem is exactly just like that one. So I'm not going to go back and read everything. I'm just going to show you how the problem works differently. Instead of cross multiplying, you multiply straight across. So 80 times 100 is 8,000. Then you divide off the one you haven't used, which is 3.2. And you get 2,500. So that would be the answer for that question. Which type of relationship is shown in the table? Well, you should have already watched the exponential video. And remember, exponential growth or decay, it grows really quick or falls really quick. So this could actually be exponential to see if it fell really quick. So it could be. Quadratic means that whatever the x is, it's squared. So y equals x squared. Did they square 1 and get 1? Did they square 2 and get 4? Did they square 4 and get 16? No, they didn't. Direct variation, it would be direct variation if I took a number out here and multiplied it to the 1 and got this number, and then did that for all of them. So 40 times 1 is 40. Is 40 times 2 20? Is 40 times 4 10? Is 40 times 5 8? No, so it's not direct. Because for direct variation, y equals kx. So you have to multiply the same number by all the k's. Then we're going to do inverse variation. Well, inverse variation says multiply these together, and if you get the same answer, then it is inverse variation. Well, it happens so when I multiply x and y, I do get the same number. So this is inverse variation. Why is this not linear? Because it doesn't look like a line. Yeah, that one's pretty easy. This is a rational function. Okay, let's do this one. It looks really interesting. The value of y varies directly. So this is direct variation. Which function represents the relationship between x if y equals 20 over 3 and x equals 30? Well, y equals kx, correct? And this says that y is 20 over 3 and that x is 30. And then I have these equations. So all we have to do is take the number here that I'm circling and plug them in and see which one tells us a true statement on the calculator. So all you have to do for this question is remember y equals kx, even though it looked really hard. Y equals kx, this is y, this is x. Figure out what k is. So here we go. Control divide 20 over 3 equals, let's try 200 times 30. Does it say true? Nope, that's not the answer. So now try 2 over 9. Bring him down. Take the 200 out. Control divide 2 over 9. True. That's the answer. Just that easy. Next question. Okay, I want to know which below represents this graph. So 2 ways to do it. Control dock. And you want to graph it in standard form. So do menu 3 2 1 3. And I'll do that again. Menu 3 4 graph. 2 for equation, 1 for I'm graphing the equation that is a line, 3 standard form. So that code was menu 3 2 1 3. And now we can type in a 1, then -3, and then 12. So which one looks like that one? It would have to be C. What else could you have done? solved it for y, so move that over, you get negative x plus 12. Divide by negative 3, so that's 1/3 x minus 4. 1, 2, 3, 4. Negative 4 is the y-intercept, up 1 over 1, 2, 3. Looks like that is the answer, and then you could have graphed this in the calculator to see that it matches C. 22, solve them for y and then see which one matches. So the top one would be add 3x, 16 would be minus 16, then divide by the 8. So y equals 3 over 8x minus 2. And it's not at minus 2, it's at plus 2. So minus 3x because he's positive, minus 16 because he's positive, and divide by negative 8. So we get positive 3 over 8x plus 2. Well, I like plus 2, but this is positive, and this slope is going down, so it's not that one. Solve this one. I'm going to do plus 3x plus 16 divide by negative 8. Now that gives me negative 3x, 3 over 8x minus 2. So I'm at positive 2, so it has to be this one. Minus 3x plus 16 divide by 8. That says go to plus 2, go down 3, over 1, 2, 3, 4, 5, 6, 7, 8. Check the answer. Alright. Which set of ordered pairs contains only points that are on the graph of the function? So, which set of ordered pairs contains only points that are on the graph of this function? So what I would do is put this in the calculator and figure out which is the answer. You can plug in the x values if you want, but to save time, so that you can spend more time on the questions that are hard, I would type that in the calculator. So, control doc, add a graph, 12 minus 3x gives me control T. Okay, so at negative 3, is it negative 27? No, so it's not 8. At negative 18, is it 10? No. At negative 5, is it 27? Yes. At negative 1, is it 15? Yes. At 8, is it negative 12? Yes. Well, there's my answer. Okay. So moving on. Which of the following is not a correct description of the graph of the function y equals negative 2x minus 7? It says that the graph of the function contains the point negative 2, negative 3, and the x increases by 1 unit as the y decreases by 2. That's describing slope. So the slope is m, which is negative 2 over 1, y over x, rise over 1. So is this decreasing by 2? Yes. Is it increasing by 1? Yes. So this part is right. Is negative 2, negative 3 on this line? Graph it and look at the table. If not, plug it in. Negative 2 times negative 2, because that's x, minus 7. So negative 4, positive 4, because a negative times a negative is a positive, minus 7. Dig 7, come back 4. I'm still under the ground 3. So yes, that is a point on the graph. So this is not the answer, because it wants which one is not correct. The graph of the function contains the points. So look on the table and see if that is true. Control doc, add a graph, negative 2x minus 7. Control T, and I see negative 1, negative 5. I see 2, negative 11. And I see 4, negative 15. So this is true. The graph of the function is a line that passes through 0, negative 7. Well, of course, because that's the y-intercept. How do I know? Because x is 0. That means that's that last number. If you don't know, you can look at the calculator, Control T, and hit menu. You need to zoom a little bit, and we're going to zoom out one time, escape, and that is 7. You can count it. That's negative 7. So that part is right, and it says it has a slope of negative 2. Well, duh, m's negative 2, so that's true. this one must be wrong, which means you look at the table, and let's see, 0, -7, that's true. 1, -9, that's true, but is 3, -1 true? No, 3 is at -13, so that's wrong. That's the false statement. Okay, how many more do we have left? I am going to skip this one. The answer for this one is C. I'm going to let you read over that one. The answer for this one is C. I'm going to let you read over that one. And I'm going to let you practice this now using your calculator and plugging in values. But I do want to talk about these two. Which of the following would be an example of a linear function? Linear means one-dimensional. It means that the exponent on the x is no higher than 1. It means that it gives you a line when you draw it. Volume is going to be x cubed, so that's not linear. Area, if you think about the units when you're finding area of anything, it's always squared, so that's not linear. Y equals x is linear, the linear parent function. And 1 and 1 gives me a linear parent function. 0 and 0 gives me a linear parent function, but 1 and 2 don't. That should be 2 and 2. And then this one here, they should both be -1 or both be 1. You could have also graphed this to see that it's not linear. This one here is quadratic because 3 squared is 9. 6 squared is 36. That means this. When I plug in x, I get 6 squared, 36, so 6 times 6. 3 squared, 3 times 3 is 9. This is not linear. Which leaves one choice, and that's the cost of a t-shirt. That's because the cost of the t-shirt is going to be consistent. If you pay $12 for the t-shirt, even with the tax, it's going to be consistent in the price based on how many you buy. So if I buy 1 shirt, it's 12. If I buy 2 shirts, it's 24. And of course, you add the taxes, but it will come out as a linear equation. The next one, which of the following can be used to represent a linear equation? That's area, so that's not linear. That's volume, that's not linear. And it says square meters. Square meters means area, kind of like the area of a circle or the area of a cylinder. It has square units, so it would not be that. It would be the purchase of a t-shirt, even including that tax. That would be linear. That concludes the packet on linear. Again, you would have to try that one on your own, this one on your own, and this one on. Can you see me? Probably not. Let me do that again. Do this one by yourself, this one by yourself, and this one by yourself. And that concludes the video. Sorry you couldn't see me at the end, but I redid it for you. Good luck and good night.